Hey, what's up, Mr. Sutter here? Today we're going to be talking about energy. Right, so what is energy? Energy is the ability to do work. Now, what's work? In physics, work occurs when a force acts on an object to move it some distance from a start point. So we have this guy, he's pushing a box up an incline. So the man is performing work. As he's pushing the box, he's exerting a force across a distance, and therefore he is doing work, which takes energy. Energy is measured in joules or calories. There are a number of different types of energy, but all forms of energy can be classified as either potential or kinetic energy. All right, let's look at kinetic energy. Kinetic energy is the energy of motion. If an object is moving, then it has kinetic energy. The amount of kinetic energy depends on the mass and the speed of an object. The greater an object's speed and the greater an object's mass, the more kinetic energy it has. Kinetic energy means moving. Right? And we have this guy, he's holding onto the car here. So both the car and the man have kinetic energy because they are moving. Now let's look at potential energy. Right? Potential energy is stored energy. There are two types of potential energy. The first is gravitational potential energy, which is stored energy due to a height above the ground. And then we have elastic potential energy, which is stored energy in objects that can be stretched or compressed. So over on the right side, we have a guy, and unbeknownst to him, there is a large rock above his head. That rock has gravitational potential energy due to its height above the ground. It has a lot of potential to be moving, but it's not moving yet. But when it drops, all the potential energy will turn into moving kinetic energy. When you pull back on a rubber band and you let it go, you're storing elastic potential energy. So when you stretch or you compress a spring or a rubber band, you're storing elastic potential energy that when you let go turns into moving kinetic energy. All right, now we have this thing, it's called the law of conservation of energy. What this law says is that energy cannot be created or destroyed. It simply is converted between forms. So the total amount of energy is always going to stay the same. So in the example here, I have a pendulum. At one point, it's at its highest point in the swing. It has no potential. It has a lot of potential energy, but no kinetic energy. It's not moving. Then I let it go, and all that potential energy starts turning into kinetic energy. When we're at the bottom of the swing, we have our maximum amount of kinetic energy, but we don't have any more potential. But then, once our ball starts going back up, it's going to go slower, 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 slower until it stops. So it loses kinetic energy, starts to gain potential, and then we're at the same point over here. So this point here and this point on the left, both of them have no kinetic energy, but they have the maximum amount of gravitational potential energy. Right? Same thing down here where we have this roller coaster. At the top of the roller coaster, we have 0 kinetic energy and 100 units of potential energy. So we have a total amount of 100 units of energy. We start to go down the hill here. Some of our potential energy decreases, and we start to increase in kinetic energy. My total energy is still 100. We reach the bottom of the hill here. I'm all kinetic energy. There's no more potential energy left, but my total amount of energy is still 100. I start to go back up the hill, and I lose some of that kinetic energy again, but I gain potential energy because I go up to a smaller hill. But again, my total amount of energy is still 100. Law of conservation of energy. Energy cannot be created or destroyed, never be created or destroyed. And our total amount of energy is always going to stay the same. All right, there's 7 major forms of energy. We have mechanical energy, sound energy, thermal energy, chemical energy, electrical energy, electromagnetic energy, and nuclear energy. Over here, we have a picture of a star. The star has lots of different forms of energy. In particular, it has thermal energy as heat, electromagnetic energy is light, and nuclear energy as it performs nuclear reactions in order to form that light and heat. All right, so let's look at the first one here. So we have mechanical energy. This is energy associated with motion and the position of objects. The sum of an object's kinetic and potential energy is equal to its mechanical energy. An example of mechanical energy is a bouncing ball. So if we have this ball at the top, it has a lot of gravitational potential energy. As the ball falls, some of that gravitational potential energy turns into kinetic energy, that moving energy. but it still has, so now it has kinetic energy, but it still hasn't hit the ground yet, so it still has some gravitational potential energy. When it hits the bottom here, wait for that to get out here. When it hits the bottom, the energy stored, the energy in the ball is going to be stored as elastic potential energy. So we're not moving anymore, so no more kinetic energy, but now all that energy got stored as elastic potential energy. So the ball is momentarily going to flatten, and then it'll bounce back up. Other examples of mechanical energy include moving cars, wind, waterfalls, running, and sound. Next, we got sound energy. So sound vibrates air molecules. The air molecules move these little tiny bones in your ear, and that's how you end up hearing things. The message of sound then moves to your brain. Sound can also vibrate objects. So, for example, a singer breaking glass. So that has to do with it's a phenomena called a resonance. And when a singer produces a sound equal to the resonance of the glass, they can shatter it. Next, we have thermal energy. Thermal energy is the energy of heat. The faster an object moves, the more thermal energy it has, and the object becomes warmer. An example is molten metal. So on the right, you can see we have molten metal being poured into a form here. Very, very hot. And on the left side, we can see we have a picture that is a thermal image. You might see it with night vision goggles. The red part, they're like special glasses or cameras that allow you to see heat. So these lighter parts are warmer, and the darker spots that are purple and blue, those are colder spots. Right, next we have chemical energy. Chemical energy is energy that's stored in chemical bonds. When these bonds are broken, the energy is released, and then it can do work. Examples of chemical energy include the energy stored in food, chemical energy that is stored in batteries, and chemical energy that is stored in gasoline for cars. So you eat food, your body breaks it down, and then you can use that broken down energy as your energy in order to perform your daily activities and heat your body. Then we have batteries too. Inside of batteries, we have different chemicals, and the combination of these chemicals allow us to produce an electrical charge as we convert chemical energy into electrical energy. Here we go, electrical energy. Electrical energy is energy associated with electric charges. Examples include lightning and static electricity. Next, we have electromagnetic energy, also known as light energy. This is energy that travels in the form of waves. It's also called light energy or radiant energy. Examples include visible light, that's the light waves that you can see. X-rays, those are the ones that allow you to see your bones. And ultraviolet rays, those are the ones we get from the sun. Those are the reason why we put on sunblock, why we have UV protective sunblock. Right, here's an example of my electromagnetic spectrum. And here is a light bulb representing visible light energy. Next, we have nuclear energy. This is the energy stored in the nucleus of an atom. We have nuclear fission, which releases energy by breaking a nuclei apart. Nuclei is the plural of nucleus. So nuclear fission breaks these nuclei apart. Nuclear fusion releases energy when less massive nuclei combine to form a more massive nucleus. So an example is heat and the light of the sun. But what does that even mean? Those are really complicated terms there. So you can think of it like this. When two cars crash, it makes a lot of noise and there's flying parts everywhere. So when you smash two atoms together, there are parts of the atom that fly off as well. And those things we can think of as energy. So when you smash these atoms together, they release a lot of energy. Here's an example of nuclear energy. We have a nuclear power plant, which converts nuclear energy into electrical energy. And we have nuclear bombs, which convert nuclear energy into electromagnetic energy, such as X-rays and gamma rays, which is why nuclear bombs end up releasing a lot of radiation, which causes cancer in people. It also releases a lot of thermal energy in the form of heat, hence the big fireball, and the sound energy it releases when the bomb detonates. All right, that's going to wrap it up for energy. Thanks for watching. I hope you learned something, and I'll see you in the next video.